Hey math enthusiast, I'm here to go over the notes for section 8.3, which deals with proving a quadrilateral is a parallelogram. So in this section, we're essentially just using the converse of all the properties we've already learned about a parallelogram. Starting with the fact that opposite sides are congruent. So if that's true in any quadrilateral, automatically that's going to make it a parallelogram. So in this case, if I know that AB is congruent to DC and BC is congruent to AD, then that means that ABCD must be a parallelogram. And the same goes for the angles. So if you have a pair of opposite angles in a quadrilateral that are congruent, then automatically it's going to be a parallelogram. So if angle A is congruent to angle C and angle B is congruent to angle D, then I know ABCD is a parallelogram. So for this first example, AB, DC, they represent adjustable supports of the basketball hoop. And then I want to explain why AD is always parallel to BC. So I'm essentially just trying to show that this actually is a parallelogram. All right, and the reason is, obviously, because these opposite sides, both pairs, are congruent. All right, so I'm essentially just using this first property that we listed above. All right, if that's true, if those opposite sides are congruent, then automatically it's going to be a parallelogram. So that would be my explanation. The next converse is slightly different because it only involves one pair of opposite sides. And in this case, they need to be both parallel and congruent. So we can see the arrow marked on here and one tick to show that they are actually congruent. So in this case, if BC and AD are congruent and BC and AD are parallel, then ABCD is a parallelogram. And the next one is one that we did discuss in the previous chapter. So if those diagonals in any quadrilateral bisect each other, then automatically I know it's going to be a parallelogram. So if you remember, this point is essentially the midpoint for both my diagonals. So I can put these tick marks on here to show that they are congruent. So if BD and AC bisect each other, then obviously it's a parallelogram. So for these first couple examples, I want to figure out whether or not this is a parallelogram and explain why or why not. So for A, it looks like we do have some sides that are congruent. So this one's congruent to this side, and this side's congruent to this side. The problem is the sides that are congruent are not opposite sides. So essentially what I could have here, if I were to redraw it, is maybe something more like this, like a kite. Just because you have two consecutive sides that are congruent doesn't mean it's a parallelogram. So in this case, no, because opposite sides are not congruent. For B, we do have a pair of parallel sides, top and bottom. We do have a pair of congruent sides, but they're not the same sides like this property up above. Okay, so in this case, it's going to be no. And if I were to redraw it, it might become more obvious to you. So the top and bottom, the only thing I know about them is they're parallel. So that could be true for a trapezoid, and the left and right are congruent. Well, this is essentially the same picture I have up above, but now it becomes more obvious that it's not a parallelogram. So no, because it's not one pair of sides. They're both parallel and congruent for B. As for C, it looks like my diagonals are marked. So we have 7 and 7, and then we have 4 and 4. In this case, I'm using this last property that we highlighted in the notes. The diagonals bisect each other, so yes, it is a parallelogram. Now before I get to the next part of the notes, I want to jump to the end where it kind of sums up all the ways that I can prove a quadrilateral is a parallelogram. So I can use the definition, opposite sides are both parallel. Or I could use the fact that opposite sides are congruent. So this is theorem 8.7. Or I could say that opposite angles are congruent. This is theorem 8.8. one pair of opposite sides are both congruent and parallel. This is theorem 8.9. And then the fact that the diagonals bisect each other. This is theorem 8.10. So I'm going to use these numbers as an explanation as to why a figure is a parallelogram. So for the next example, we have quadrilateral GHJK, and they give me a bunch of angle measures to throw in as well. And I want to find the measure of angle K, and then figure out, is this actually a parallelogram? So kind of draw it like maybe it is a parallelogram, maybe it isn't, I'm not really sure. I have GHJK in that order, and then I'll fill in the angle measures that I do have. So we have G is 55, H is 125, J is 55, and I want to solve for K. Remember that a parallelogram, all those interior angles have to add up to 360 degrees. All right, whether it's a parallelogram or any quadrilateral, doesn't really matter. So I'm going to subtract all the angle measures that I do have and see what's left over for K. So it looks like K is 125 degrees. So now it becomes obvious. My opposite angles here are congruent. So that means this must be a parallelogram because of theorem 8.8. Next couple examples, they want a value for x that's going to make that quadrilateral a parallelogram. For problems like this, I would start off and just assume that it is a parallelogram. Okay, well, for A, if it is, then these diagonals are going to bisect each other. So that means the left and the right are going to be congruent. So I can say that 5x would have to be equal to 2x plus 9 for it to be a parallelogram. Well, in this case, I'm going to end up with 3x equals 9, so x equals 3. Then if I plug it back in, it looks like I'm going to have 15 and 15. Next example for B. Once again, just assume it's a parallelogram. The top angle, 4x plus 5, and the adjacent angle is 3x. Remember, those adjacent angles in a parallelogram are supplementary. So we have 4x and 3x plus 5. So I'm going to have 7x equals 175, and it looks like x equals 25. So it looks like in this case my angle measures are 75 and 105, which do add up to 180. So for the next example, I want values of x and y so that the quadrilateral is a parallelogram. Once again, let's just assume that it is a parallelogram. That means my opposite sides are going to be congruent. So let's jot down a couple equations. I'm going to start with that 3x plus 3y equals 21. And then we'll do that 2x plus 4y equals 6y plus half x. So in this case, I have two variables, obviously x and y, and two equations. So I'm dealing with a system of equations. Well, I have a couple different methods to solve this. I can use elimination, I can use substitution, or I can use graphing. Let's try to avoid graphing at all costs. First thing I notice for this top equation is I can actually divide everything by 3. So let's start with that and let's simplify that equation. So that's just going to give me x plus y equals 7. Second thing I notice is for this bottom equation is I got this half here. So to get rid of that, to make it a little bit easier so I don't have any fractions to deal with, I'm going to multiply everything in here by 2. So now I'm going to have 4x plus 8y equals 12y plus x. And then my other equation from up above, that one was just x plus y equals 7. Okay, so now I have two equations that are going to be a little bit easier to deal with. I think my best bet in going around to solve this is going to be to use substitution. And to do that, I'm going to rewrite this equation just in terms of x. So it's going to be x equals 7 minus y. Or you could say negative y plus 7. Either case, doesn't matter. So as I said, I'm using substitution. So now I'm going to go back to the equation above it, and I'm going to replace this x and this x with 7 minus y. So I'm going to have 4 times this whole quantity, 7 minus y, plus 8y equals 12y, plus, I'm just going to do this in parentheses, 7 minus y. But it's not going to change if I remove the parentheses because it's addition right here. Okay, so let's distribute and simplify this a little bit. So it looks like we have 28 minus 4y plus 8y equals 12y plus 7 minus y. Combine some terms, 28 plus 4y, 11y plus 7. Looks like I'm going to end up with 21 equals 7y, so y must equal 3. So I have 1 out of 2 variables, but I'm really more than halfway there. So since y equals 3, I'm going to go back to this equation. And I know that x equals 7 minus y, which is now 3. So I know that x equals 4. So my final answer is going to be 4, 3. X equals 4, y equals 3. And if I plug it back into my picture, we're going to end up with 21, which matches up to the opposite side. And then the top side is going to be 20, and the bottom side is going to be 20. Now, there are definitely other ways to solve this problem. All right, I just chose a method that appeared easiest to me. So for this last example, I want to show that quadrilateral KLMN is indeed a parallelogram. Well, there's a couple different ways I can do this. One, I can show that these opposite sides are congruent. Okay, that could work. Or I could do one pair of opposite sides is congruent as well as being parallel. Or I could show that both pairs of opposite sides are parallel. Or I could, if I really wanted to, I could find the diagonals and show that they do actually bisect each other. All right, you have several different options. Now I know the distance formula can be tedious, so I'm going to go with what I believe might be the fastest method and just try to show that the opposite sides are parallel. So let's start with these two that I highlighted. Now, if you remember, to show that two segments or two lines are parallel, you need slopes. So I want to get the slope of KL, and I want to get the slope of NM. So I can just plot it right out on the graph. Looks like I'm going right up to right 2 over 2, which is really just going to give me 1. And it looks like I have the same for N and M, 2 over 2, which gives me 1. So now I know that these two are parallel. Now I'm going to go back and check my other pair of opposite sides. So now I'm focused on KN and LM. So are these two going to be parallel? Once again, I'm going to need some slopes. Slope of LM, slope of KN. So it looks like for LM, we're going down 4, so that's going to be negative, and right 2. So negative 4 over positive 2, which is going to give me negative 2. And lastly, for KN, looks like the same deal. I'm going down 4, right 2, which gives me negative 2. So now I've shown that these two are parallel. So my reason then for this being a parallelogram is essentially I'm just using the definition. The definition of a parallelogram is the opposite sides are congruent, and I just showed that by finding all their slopes.